Okay. Can you see my screen?
Yes.
All right. Okay. So this is I went with a domestic washing machine. So my washing machine was the LG WM 4000 HWA. The transfer function is this. The derivation is here. So it was 39 kgs, and then we found the angular frequency and the zeta value. Okay, so let me show my simulation. Okay, so I simulated for displacement, then for velocity, and then for acceleration. So the results are kind of like this. This is the displacement. Then the second one is the velocity, and the third one is the acceleration. So the damping coefficient is 0.7, which is industry standard for second order vibration systems, which this is a second order vibration system. And the overshoot for my results are only 4.6%. So it becomes steady very soon without, as you can see from the displacement curve, that since the overshoot is pretty low, the the steadiness is quick without excessive displacement. And then my setting time is 1.5 seconds. So it the spin cycle, like the vibration of the spin cycle, can be suppressed very quick. And it has a pretty strong frequency separation, which I mentioned in like the derivation. Um, and then yeah, it's a domestic washing machine. So the specifications are pretty readily available, which is why I chose this washing machine. Do you want to share yours now? I'll stop
Yeah.
sharing my screen then.
Okay, so
Okay.
I'll go next.
Okay.
So the washing machine that I modeled is the MWF 100J7 by Milner. So it has a 100 kilogram capacity for load. These are the specifications for it in their specification sheet. Now, so from their diagrams, I made this free body diagram where we are considering two masses. One is the tub mass and one is the mass of the entire washing machine or the frame or wall of the washing machine. So the force is mainly operating on the tub, which is why this mass is our main primary concern here. I have springs K1, K2 connected to both the washing machine tub and the frame, and damper C1, C2. Uh, then from here, I derive the equations of motion, and using Laplace transform, we have the characteristic equation here. So based off of this, I made this simulating diagram. So we have this part above here is for the tub, and this part below is for the frame. And there is a MATLAB code for it where I input all the parameters like for the variable parameters. Then if we run it, yeah, then I will get these two graphs. This first one is for the washing machine tub. So for the tub, the first one is acceleration, then velocity and its displacement. Using a step response, I'm getting this overshoot here. Then for the frame, since there is no direct force on it, so it's mostly non-moving, as we can see. So our main focus for this design will be on the tub, but I'm considering both the masses to simulate as closely to a real world washing machine as possible.
Yeah, think makes sense. Um,
Okay, so we need to select which one we want to proceed with.
the thing is, so for when you do the transfer function, do you plan on using both the masses?
For now, I'm only using for uh, x x1 or like the tub because that's the one we want to control the vibration for because this is the
Okay.
one that has the most vibration as you can see in the plot. The frame is more or less non-moving. The the tub is the one that is of our main concern.
Yeah, I mean, we will have to. Hmm, let's both of them. I guess for time's sake, I'm saying I really like the industrial one.
Mm.
Um, but my main concern is about the like how we will do the connection for the PID controller and the actuator, you know?
Should we take this offline?
Hmm? I guess we think on it and then we message in the group and like figure out which one works the best. You can share I will share my outputs in the group as well. You can share yours and then we can both like study and then figure out which one.
Uh,
Okay? All right then.